Hello, my name is Ray. I'm the Ray in the Ray code. In this video, I'll be covering the Chain of Responsibility Design Pattern, and I'll be using C++. The Chain of Responsibility Design Pattern is a behavioral design pattern, and for a demo on each design pattern, stick around. I even give demos in other programming languages also. The current list is C++, C#, Java, JavaScript, and PHP. Please find me on other social media platforms, X, Facebook, LinkedIn, etc. TheRayCode.com and TheRayCode.org are two of my own websites. I keep the materials separate. On TheRayCode.com, I try to package the material into something that I can sell. And TheRayCode.org is sort of like a blog. Anyway, become the Raycode groupie. The Chain of Responsibility Design Pattern allows an object to pass a request along a chain of potential handlers until an object handles it or at the end of the chain is reached. In essence, it decouples the sender from the receiver by letting more than one object handle the request. The pattern consists of a series of processing objects where each object contains logic that defines the types of commands objects they can handle and how to pass off the rest to the next object in the chain. Why C++ programmers should study the Chain of Responsibility Design Pattern. Decoupling of senders and receivers. One of the most significant benefits of this pattern is the reduced coupling between the sender of a request and its potential receivers. C++ developers can maintain and modify senders and handlers independently. Dynamic handling. Chain of Responsibility allows dynamic linking of handlers, offering flexibility on how requests are handled. This can be especially beneficial in C++ applications where performance and system resource allocation play a crucial role. Simplified code. Instead of having complex conditional logic to determine which handler should process a request, C++ programmers can create cleaner, more maintainable code structures where each handler is responsible for its own processing logic. Scalability. As new handling logic or functionality is required, new handlers can be introduced into the chain without disrupting existing code. This makes the system more scalable and easier to extend. Flexibility and object assignments. In situations where the handler for a specific request might change at runtime or where there's a need for a dynamic determination of handlers, this pattern proves invaluable. Advanced object-oriented concepts. The Chain of Responsibility relies on object-oriented principles like loose coupling and delegation. For C++ programmers, mastering such patterns can deepen their understanding of how to design effective, modular, and extensible OOP architecture. Applications and middleware. C++ is often employed in systems where middleware plays a significant role, such as in networking or communication systems. The Chain of Responsibility pattern is a common approach in such contexts where a request like a packet or a message may pass through multiple stages or layers of processing. Performance concerns. Since C++ is a language often chosen for its performance capabilities, developers must ensure that the chain doesn't become too long, leading to performance overhead. Understanding the pattern will help developers make informed decisions about the balance between design, flexibility, and performance. In conclusion, the Chain of Responsibility Design Pattern provides C++ developers with a structured and scalable approach to handle requests. Given the complex performance-critical systems often developed in C++, understanding this pattern can equip a developer with a versatile tool to ensure code clarity, system scalability, and efficient design. Chain of Responsibility for C++ students, UML. Handler defines the interface for handling requests, stores a reference to the next handler, forwards requests if it can't handle them. Concrete handler handles requests it is responsible for, decides whether to process or forward, passes unhandled requests to successor. Client sends requests to the first handler, does not know which handler processes, relies on the chain for handling. Hello, I'm Ray, the Ray in the Ray Code. Imagine for a moment that you have a series of people in a room. Each person is trying to avoid doing a specific task, so they keep passing it down the line to the next person saying, "It's not my job." That's essentially the chain of responsibility pattern. The idea is to decouple the sender from the receiver by allowing multiple objects to handle a request. Let's look at a C++ example where different members of a household are trying to avoid doing the dishes. We start with the dishwasher class. We have the dishwasher class structure. Dishwasher will process the dishwashers. We have a default deconstructor for dishwasher. We set this dishwasher to the next one, and we set wash dishes to 0. We have protect the next dishwasher. Let's create the teenager class as an actor in our story. We have the teenager class structure. We make it a dishwasher object by extending it with the dishwasher, of which we need to include at the top. We add some code to reflect if the dish is a plate, then wash it. But if the dish is something else, we pass it along and say, "Not my job." Let's create a parent class. The parent too can wash dishes and is a dishwasher object, so we extend it with the dishwasher class. If the dish is a pot, then the parent says, "Alright, I'll wash the pot. Else, not my responsibility, I cooked the meal for you." Then she passes it to the next dishwasher. Now, let's create a robot class. The robot never says no to a responsibility. The robot says, "Fine, I'll do whichever dish is passed to me." Now, let's go to the main class for our demo. At the main class, we include teenager, the parent, and robot. Notice we do not need to include IO stream because that was already included in the dishwasher object. The teenager is make shared, so is the parent and the robot. Make shared parent and make shared robot, respectively. Teen points to set next parent and parent points to set next robot. We attempt to wash a plate. We attempt to wash a glass. At this point, we are ready for our demonstrations. We witness in this example, when you try to wash a plate, the teenager reluctantly agrees. But if anything else, they pass it along. The parent only washes pot. If anything else, they pass it along. The robot, being the last on the chain and the most responsible one, washes anything that reaches him. My name is Ray. Always code with a smile. SWOT analysis of the design pattern chain of responsibility, a behavioral pattern for a C++ student. S. Strengths. Dynamic workflow allows flexible request handlers by passing it along a chain of handlers. Extensibility. Adding new handlers is straightforward without modifying existing ones. Loose coupling. Decouples sender and receiver, enhancing modularity. W. Weakness. Performance overhead. Long chains can degrade performance if request travels all handlers. Debugging challenges. Tracing request paths through a dynamic chain can be difficult. Order dependency. Misordering handlers may lead to unexpected outcomes. O. Opportunity. Middleware design. Commonly used in designing middleware chains for server requests or logging. Authorization layers. Implements multi-step authorization process effectively. Event handling. Useful in GUI applications for propagating user actions. T. Threats. Misuse risk. Applying it to simple processes may overcomplicate the design. Scalability concerns. Overly long chains might hinder scalability. Similar options. State or observer patterns might handle specific cases better. Well, that was my video. Please find me on all the social media accounts like Facebook, X, LinkedIn. Also, visit my websites, theraycode.org and theraycode.com. I keep them separate. For one is for classes I sell, and the other one is for a blog that I keep. Invite a friend to theraycode.com or raycode.org or Raycode YouTube. Become the Raycode.groupie, a groupie.